Hey, welcome back to your favorite technical mathematics class. We're going to take a look at scientific notation today. And these are really useful in scientific applications, technical fields, when you got really large or really small numbers. You know, for example, this huge number, right, that represents Coulomb, or this very, very small number for copper expanding. Scientific notation really comes into play nicely with those types of numbers. And so the way that scientific notation works is you write it in the form a times 10 to the nth power. Now this a value has to be greater than or equal to 1 but less than 10. And n is an element of the integers, right? So if you remember the integers, a set of integers, that's what the power has to be, right? One of those. There's your set of integers. So for example, let's do some scientific notation to standard notation, and then we'll go the other way around. Okay, so 4.5 times 10 squared. So what this means is you have 4.5 and it's being multiplied by 10 squared. So 10 times 10. In other words, you got 4.5 times 100. Well, if you take 4.5 times 100, it'll move that decimal to the right 2. And so one way you can remember this is you're going to move it right 2. 4.5 times 10 squared. So this decimal moves right 1, 2, 450. But again, make sure you understand what it means. So let's do this second one here, 4.5 times 10 to the negative 2. So you got 4.5 times 10 to the negative 2 means 1 over 10 squared. Remember that negative exponent. And so what we have here is we have 4.5 times 1 over 10 times 10 is 100. And then we'll go ahead and multiply those. The numerator is 4.5 times 1, 1 times 100. We got 4.5 divided by 100. And if you punch that in, you'll get 0.045. And so the way that you can remember to do this is if you have a negative exponent, move the decimal left 2. So right now it's right here, 4.5. Move it left 1, 2. So it's right there. That's where you get the 0.045. Move it left 2. So let's do it that way. So now we've got 4.2 times 10, 10 to the 5th. And, 10 to the 5th is... let's see, that would be 100,000, right? So this is 4.2 times 10 times 100,000. But we're going to do it this easy way, where we just move it to the right. Oh gosh, what's this doing? Right 5 spots. So 4.2, we're going to move it to the right 1, 2, 3, 4, 5, right there. So it's 420,000, right? So if you were to get on your calculator and multiply 4.2 times 100,000, in other words, 5 tens, you get 420,000. This next one, we're going to go left 5. So right now we have 0.24. 1, 2, 3, 4, 5, right there. So 0.1, 2, 3, 4, 2, 4. 0.000024. In other words, that's the same as taking 0.24 and dividing it by 100,000. That gives you that 0.000024, right? And so you can check these, feel free to do it with your calculator. Check them with your calculator. I would like you to do them by hand first. Go ahead and check it with your calculator. So if you pull up Desmos, desmos.com, that scientific calculator. Let's do that first one. We had 4.5 times 10. Oops, that's not doing times. I'm going to have to use that times button. 10 squared. You see how you get 450. The second one was 4.5 times 10 to the negative 2, or 0.045. The third one was 4.2 times 10 to the 5th, so 420,000. And our last one was 0.24 times 10 to the negative 5. It looks like it's struggling to show that here. As I guess the scientific calculator here will just show the scientific notation. But this is 0.000024, as we showed here on this last one right there. All right, now let's do standard notation to scientific notation. And so what you want to do is you want to have it in this form. Write it again. A times 10 to the nth power. Now, again, this A has got to be greater than or equal to 1, but it's got to be less than 10. So the first thing you do is you're going to move this decimal point. Right now it's right here, 123,000. The decimal's right there at the end. And you got to determine, where is it supposed to be? Well, I don't want it right here, because then I'd have 123. That's too big. I do want it, how about right there, 1.23. That's the number that I want. So I got to move it to there. How many times do I move it? 1, 2, 3, 4, 5. So this is 1.23 times 10 to the what? To the 5. Because if we check this, remember, we got to move it right when it's in scientific notation and it's positive. We'll move it right 5. 1, 2, 3, 4, 5. See how that's 123,000? That's back to what we had. So again, here's our answer on this. Let me highlight it. 1.23 times 10 to the 5th. On this next one, where are we going to put the decimal? Right now it's 0.0168. I don't want to put it right there. I'd have 168. I don't want to put it right there. That'd be 16.8. Remember, we want the number to be less than 10 but greater than 1. So I want it right there between the 1 and the 6. So I want to move that to the right 2. So 1.68 times 10 to the negative 2. Okay, so let's check it. To the negative 2 means I'd go left. So left 2. Again, I'm looking at it in scientific notation, so I'm going to move it left 2. So 0.0168 if I move it left 2. There's our original number. So we did that correctly again. Let's do this next one. Where am I going to move it? Right now the decimal's right here on the end. And I'm going to move it between the 2 and the 0 right there, 2.01. So how many positions do I have to move that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.01 times 10 to the 9th. 2.01 times 10 to the 9th. So again, make sure you check that by moving it right 9. 2.01. Move it right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then check your answer. And there it is, 2 billion, 10 million. So 2.01 times 10 to the 9th. Let's do this next one. We're going to want to put it between the 5 and the 2 right there. How many positions does that move? 1, 2, 3, 4, 5. So 5.2 times 10 to the negative 5, because I'd have to move it left 5 to get back to my number. I'd have to move it left 5. Let's check it. 1, 2, 3, 4, 5. That should be my original number. There it is. 0.000052. Last one. We want this one between the 4 and the 0 right there. How many positions? 1, 2, 3. 4.081 times 10 to the negative 3. Again, let's check it by moving it left 3. This is our proposed thing. Let's move it left 1, 2, 3. There it is. 0.000481. That's our original number, and that's how you want to. That's how you can check those as well. Thanks so much for watching Scientific Notation. We'll see you next time.